When we started the other day, I told you that chemists like to have multiple words for the same thing. This is one of those times. So an addition or a synthesis reaction is also called a number of other things. Name one. Composition. Name another. Combination. What you're supposed to recall, it's a couple of things happening together. Before you start writing, let's start this. I'm going to explain the types of chemical reactions using kids and the prom. Are you ready? This is my prom. I'm allowed to say whatever I want about this prom. This is Adam's prom. So here we go. To describe an addition or a synthesis reaction in our prom scenario, one atom is attracted to the other atom and they become a couple. A bonded couple. So, whereas in the reactants you had two separate atoms, in the products you have a bonded set of atoms. Okay. The clue, if you were to see this written out and you were to have to decide what type of reaction is this, there is one product. There is one product. What do we call this? We call it, in slang terms, the hookup. A plus B yields AB. AB are not just hanging out together, they're chemically bonded together. Now you may write all that down. Okay, the second type of reaction that we're going to talk about is the decomposition reaction. The decomposition reaction. So here we have our lovely bonded couple, A and B bonded together, and they're sitting on the bench and they're talking about the prom. And A says to B, hey baby, I'm all excited about going to the prom. You know what? I got a car lined up and everything. And she says, you do? Is it a limo? What color is it? And he says, no, it's my mom's minivan. And what does she do? Says, I am out of here. She breaks up. She's not going to the prom in a minivan. So the hook, the clue for a decomposition reaction is the breakup. The breakup. Where you started with two atoms chemically combined, the products are separated. She is selfish. There is nothing wrong with going to the prom in a minivan. Or, what did you say? You're going in a Prius. Okay, moving on. And here we go. A single replacement reaction. All right. This is Going Home Alone. All right, I would like you to name me a hot male celebrity.
Ryan Gosling.
A not so hot.
Will
Will
Ferrell.
Ferrell. I can't remember if that's, is there an A somewhere in there? Maybe not. All right, so this is how a single replacement reaction occurs. All right, so we have our couple dancing together. And the A, the man in this scenario, taps the man and the couple together and says, I would like to dance with your date. if the date finds the man who wants to dance hotter than the man she's dancing with, what does she do?
All right.
She changes partners, and look at him, he's so sad. He's going home to his mom and said, Mama, I was having a good time, and then all of a sudden, Lucy didn't want me anymore, and now I'm walking home alone. And the mom says, you know, baby, I'm going to love you forever. And he says, great.
There's nothing real there else is so funny.
All right, well, I already broke that because it can't get broken anymore. So, only if this is Ryan and this is Will the exchange of metals take place. This one has to be more reactive. This one has to be less reactive. How can you tell the activity? On your green sheet of happiness, you have an activity series. Please find the activity series on your green sheet of happiness. Did you find it? Okay. So you can see that the activity level goes from the bottom, which is less reactive, to the top that is more reactive. So let's do this with real life atoms. Let's say this is copper and this is, potassium chloride. Which is higher up on the list, copper or potassium?
Potassium.
Potassium is, will this reaction occur?
No.
No reaction will happen. Now, let's say that this is barium and this is cobalt chloride. Which is higher up on the activity series, barium or cobalt? Barium. So barium will replace the cobalt. Got that? Yes? All right. The activity series chart will be available to you for the EOC and on your test. And if you quickly turn your study buddy over, you'll see I shrinky-dinked it really tiny, and there it is. So you can do your homework at home. All right, moving on. Now, you do recall I said that this was my prom, correct? I'm the DJ. Guess what kind of music I play?
Country.
Ew.
2 Chainz.
That's correct. Giant fan.
You played the Do-Si-Do.
Polka. Do you remember this in 3rd grade when you had to dance? You're in PE and you had to, swing your
Square
partner
dance.
around and square dancing.
Oh.
Swing your partner round and round,
Yeah.
fling her to the ground. I don't remember what happens. But at the end, what did you have to do? You had to do-si-do. What does do-si-do mean? I don't
Switch.
really know. You have to switch
Partners.
partners. In a double replacement reaction, you have to switch partners. Now, in 3rd grade, if you didn't switch partners right, it would be really embarrassing. Actually, the whole thing in 3rd grade was kind of embarrassing because you might have to hold hands with somebody that you secretly had a 3rd grade crush on, correct? You know those 3rd grade crushes. All right, what you have to be careful with here is this. You have a metal and a non-metal. In our picture, a boy and a girl. You have a metal and a non-metal. In our picture, a boy and a girl. When you change partners, you have to make sure your products are a metal and a non-metal, a metal and a non-metal. You cannot have 2 girls dancing together or 2 boys dancing together. Not in the chemical square dance. Got it? So when you do-si-do, you change partners, making sure When you're done, it's a metal and a nonmetal, and a metal and a nonmetal. So let's see what this looks like in terms of an actual equation. These are kind of not really helpful to me, are they to you? This would be the metal,
So you
and this is supposed to be the non-metal.
So you can't have a metal and a metal together.
And they have no energetic reason to combine.
Do they not have attraction towards each other? Is that why they don't?
Not,
They're opposites.
yeah, not very much. Okay, so there we go and there we go. So when we were done, if we use my color coordinated thing here, we would have a metal here, this would be non-metal, this would be the non-metal, and this would be the metal. Okay, got that? No, can't we do this with real live chemicals? Yes, we can. All right, let's say that I have sodium chloride here, and I am going to have potassium bromide here. I need to switch my partners. Sodium will now be paired with bromine, and potassium will be paired with chlorine. All right, that's fine. You cannot be embarrassing to your chemistry teacher and do this. Promise? Maybe. Okay. Here we go. I'm going to turn the lights off just a little bit so you can see this. This is an actual combination reaction. Somebody has taken a piece of potassium metal and into it they have poured some liquid bromine. The chemical reaction takes place and potassium bromide results.
Is that the brown stuff?
The bromine is the brown stuff. I can't really see in this picture. Oops. I can't really see in this picture the potassium. Okay. If I were to balance this, what would I do?
Add two to the left, or to the right side.
Just like that? Mhm.
Does it just depend on the substance to become a solid or liquid?
There are some rules. We'll learn some of those rules in a second. All right, here's another combination. We'll wait for this to start from the beginning again.
It's already.
There you go. Here is the zinc powder, and someone is adding liquid iodine to it. It gives off some really nice poisonous purple flames, purple vapor, and it makes zinc iodine. Zinc iodide. And once again, how should I do this?
All one.
It is already balanced. Right. Here is a decomposition reaction. We're starting with whatever that is, and I can't read it. We are adding some energy to it, and it is changing form. You see, it is certainly not what we started with. A single reactant breaks down into simpler substances. Okay. Here is the single reaction, the single replacement reaction. Now, you need to remember this. A metal can only replace a metal. In our picture, that was a boy, can only replace a boy. Or a nonmetal can only replace a nonmetal. Remember that hydrogen can act as, it can replace the cation in a single replacement reaction. Copper is higher on the activity series list than silver is. So it replaces the cation in the this compound, and silver is all alone. This is something we do in AP Chem. I started out with a piece of copper wire. Everybody know what copper wire is? and I dipped it into a solution of silver nitrate. What you have here is the silver on what's left of the copper wire, and the ions floating around in the solution are copper ions and nitrate ions. Let's watch this animation. Okay. It says in the next exercises, you will be, oh, that didn't help. You will be able to test several metals with different aqueous solutions. So let's start that as soon as I find my cursor. There we go. Okay, thank you. Okay, I wish I could move this over a little bit, so I'm going to minimize it and try again. No. All right. Are you ready? You need your activity series. All right, here are my different solutions. Okay, I'm going to take a strip of copper and I'm going to dip it into each one of these. And you're going to tell me if there will be a reaction or no reaction. All right, so what I'm asking, is copper higher on the activity series than magnesium? Is copper higher on the activity series than zinc? Is copper higher on the activity series than copper? No, that would be silly, they're the same. Is copper higher on the activity series than silver? Have you made your predictions? Okay. Okay. What happened?
Reacted with silver.
Okay, it replaced only this one, is that correct? These three, did anything happen? No, there was no reaction. One more time. Let's try zinc. Is it on your list?
Yes.
Okay. Make your predictions.
What's that last one, so?
Lead, PB. Have you made your predictions? How many reacted this time?
3.
3 out of the 4. Okay, we're going to do this one more time. Yes or no? Will copper replace, and what is it going to replace in this?
Hydrogen.
Hydrogen. Will copper replace hydrogen? Raise your hand if you think yes. Raise your hand if you think no. All right. Fortunately, everyone has an opinion. That means you are all thinking. Did it? Nope. Let's try nickel. Is nickel on your list?
Yes. Yep.
Okay. Raise your hand if you think yes. Uh-oh, cursor gone. Raise your hand if you think no. Not everybody raise their hand, therefore who's not thinking? Oh look, what's happening? Bubbles. Bubbles. Remove.
Oh, did we do copper
Oh,
before
it
this?
removed.
What happened?
It was a.
What happened to the strip of nickel?
Corroded it.
It corroded it. It actually, it's smaller, isn't it? It started to go away. Ah. Why didn't it put hydrogen on there?
It's discolored.
Come on, you can do that. You can figure this out one more time and we'll see what happens. Where's the hydrogen going?
It's a gas.
It's a gas, that's right. It's a gas. So it's going out into the surroundings, yep. Because if we waited long enough, what would happen to the zinc strip? It'd be gone. Yeah, it'd be gone. All right. We get this? All right. So, here are the directions in case you forget. I think I may have animated this thing on. Nope, I did not. All right. So, what you have to do, if you have, let's do one of these again. We had copper and lead to nitrate. And we want to know if a reaction will happen. We have to find the metal in the compound. There it is right here. And then we have to find the metal that would like to replace. It is right here. Is the replacer higher on the list than the one already in the compound? No. So it will be no reaction. All right. Now, let's talk about nonmetals. What is the most active nonmetal? What is the most active nonmetal? Nope. Fluorine.
Oh.
And then it would be chlorine, bromine, iodine. Good there? So what would happen if we had this reaction? Where is the nonmetal that we start with? And the nonmetal that we're going to replace, try to replace? Is the solo higher up than the one in the pair?
Yes.
Yes, so it will replace. Okay, what if I have sodium fluoride, the stuff that protects your teeth, and I would like to see if bromine will replace it? Will it go? Yes or no?
Yeah. No,
No.
Why?
because there's only.
Sodium's higher up.
Nope, we're not looking for sodium. We're looking at what the replacer is. And the replacer is a nonmetal. So we're looking to see what the deal is with the nonmetal in the compound. Bromine is here on the list. Fluorine is way up here on the list. Will this bromine replace? No. No reaction. So what I sense that you need a little help with is this. Okay, you need to recall that you replace a metal with a metal or a non-metal with a non-metal. All right, let's look at that one more time. In this scenario, what is trying to replace, the metal or the non-metal? The non-metal. In this scenario, what is trying to replace, the metal or the non-metal? Metal. Okay. Okay. One of the things that happens sometimes with a double replacement reaction is a precipitate, an insoluble solid, a new solid can be formed. Remember, a double replacement is two switching partners. So in this case, the cations will switch partners, and at the end, instead of sodium being connected to chlorine, it's connected to the nitrate. Hey, does it matter in what order you write all of this?
Yeah.
It only matters that you have them on the correct side of the yield sign. It doesn't matter if NaCl goes first or AgNO3 goes first. Likewise, it doesn't matter if you put AgCl here or NaNO3 here. Are you clear with that? All right, this is where we're going to stop for today.